Let's look at the corrections. All right. This was exercise 36. Question number 1 says calcium carbonate, CaCO3. CaCO3. All right. Reacts with hydrochloric acid, HCl, according to the following balanced equation. You've got calcium carbonate and 2HCl to give you calcium chloride plus carbon dioxide plus water. All right, 1.1. The above reaction is an example of an acid-base reaction. Define the term acid-base reaction. Define the term acid-base reaction. All right. What's the definition here? What is acid-base reaction? Acid-base reaction. Acid-base, anyone? Yes. How did you define it? Acid-base?
Oh, so I say it's an exchange reaction between an acid and a base that produces a salt.
It's an exchange. Okay, well, what are they exchanging? It says it's an exchange between an acid and a base to produce salt and water. Okay, all right. Another definition? Another definition that you've heard? Any compound? Okay. Anyone online? Anyone? How do you define acid and base reaction? Ayabulela. What is an acid-base reaction? How did you define it?
So mine was similar to the acid-base. The acid-base reaction what takes place between an acid and a base, which produces products which are water and salt.
Okay. All right, that's correct. So it's a reaction that takes place between an acid and a base to produce salt and water. All right. Or the other way to define it is you can say it's a reaction in which a proton is transferred. It's a reaction in which a proton is transferred between an acid and the base, or you can just say it's a reaction in which a proton is transferred. That's the other way to define an acid-base reaction. Right. Come again. Which one? The first one or the second one? Second one. It's a reaction in which a proton is transferred. It's a reaction in which a proton is transferred. By this case, what do we mean a proton? We're not talking like proton as in a proton, but we mean H plus. H plus, we call it a proton. Why do we call it a proton? It's because hydrogen, when it loses an electron, the particle that is remaining in hydrogen is a proton. All right. So we call it a proton. But proton is not going like as a P. It's just going as H plus. H plus. It's a hydrogen that has got only one proton. My system is kind of freezing. I'm not sure why. Huh? It is a reaction in which a proton is transferred. The reaction in which a proton is transferred. Right, by proton we mean H plus. We mean this H plus. That's proton. H plus. My system is getting slow. I'm not sure why. H plus. Right, so H plus is transferred between two substances, right? And that H plus, we call it a proton. Why do we call it a proton? Because hydrogen has got one electron and one proton. So plus means it has lost the only electron that it has. So the particle that remains is a proton. That's why we call this one proton. Okay, that's another way to define it, but the first one is also good enough. All right, let's move on to the next one. The next part. The next part, just bear with me, my system is a bit slow. So the graph below shows the relationship between volume of carbon dioxide gas, CO2 formed, and the mass of pure calcium carbonate, the mass of pure calcium carbonate. So let's have a look. All right, so the first one, whenever you're given a graph, you need to know. Just study the graph, understand what is happening here. What are the things that you need to understand on the graph? You need to know what is my independent variable. All right, what is an independent variable? Is the variable that you find on the x-axis. So what is our independent variable here? It's mass of calcium carbonate. What is our dependent variable? It is the amount or what you get on your y-axis. So your volume of carbon dioxide becomes your dependent variable. That's point number one. Point number two, on a graph, you need to know the scale that is being used here. And what does each small box on every axis, what does it represent? You need to know that, all right? So let's have a look for this part here. The first one, it says you've got 0 and you've got 0,2. Right? So want to know each small box here, what does it represent here? Each small box here, what does it represent? Right, so what are you going to do? You're going to calculate, you're going to count the boxes that we have. The boxes that we have here is 10. 1, 2, 3, 4, 5, up until 10. Yeah. Okay. Right, so as I was explaining here, I'm saying you count your small squares here or your boxes here, you find there are 10, all right? And what is the, from here, it's 0 up until it's 0,2. So what does each box represent? You're gonna have to divide. So it's gonna be 0,02, 0,02 divided by 10. To divide this 0,02 divided by 10. Right, divided by 10. So each one square here represents, what is 0,02 divided by 10? What do you get? You get 0,002. So you get 0,00. You now have 2 zeros before the 2. Right, so each box represents 0,02. Right, so that's what you need to note when you're doing this. Right, then you go to your y-axis. Y-axis you've got from 0 to 10, and you also have 10 boxes here or 10 lines. So it means each one line here represents 1. So the first one represents 1, then the next one represents 2. This one represents 2. So you're gonna have your 2 up until you get to 10. So it's 1, 2, 3, 4, 5 up until 10. So each one here represents 1, 1, 1, 1, 1. Yes. Come again. Okay. Fine. So this is the information that you get from the graph, right? That you need to apply. So let's look at 1.2. 1.2 says from the graph, determine the volume of carbon dioxide produced when 0,072 grams of pure calcium carbonate reacts. So you have to use your graph to determine the answer. Clear?
That is hard.
Right. Okay, let me just mute this. Someone looks like talking there. Okay. Mute all. Okay, now you go to your graph, right? And you check where is 0,72, right? But when you check from the looks of numbers here, you don't have 3 decimal places. So what are you going to do? Try to put 3 decimal places. So this one looks like a 0.20. This one becomes 0.040, like a 40. That becomes a 0.60. That becomes 0.80. Right, this one becomes 0.100, which is like 100. And this one becomes 120 or 0.10. Just for you to be able to identify this. So here you're given 0.072. 0.072. What do? You look for it. It's going to have to be between the 60 and the 80. So it's somewhere here. And you count in twos. So this becomes 0.062. So basically, the 0.02 that we have initially here, it means here you've got a 0. The next box becomes 0.002. The next one becomes 0.004. The next one becomes 0.006, 0.008, 0.010, 0.012, 0.014, 0.016, 0.018. Then you come to 0.20 and so on and so on. Now for you to identify your 0.072, you start from here, 0.060, 0.062, 0.064, 66, 68, then you've got 0.70, then you've got your 0.72. So this is your 0.72 here, this one here. All right, let me just choose the red one, the red color. Right, so your 0.72 is somewhere here. That's 72, 74, 76, 78. So that's 72. So you need to follow this on the line, in a straight line, till you get to the point here. Then you move across. Then your answer is going to be here. All right, what is that value here? All right, that's 20. We are counting in ones, so it's 20, 19, 18. So that becomes 18 then. That becomes 18. And your units, those are your units there, cubic centimeters. So your answer for 1.2 becomes 18 cubic centimeters. 18 cubic centimeters. Yes?
If I say approximately 19 centimeters.
You said 19.
Yes, sir.
Reason being, because you're 19, your line, if you check your line here, it does not go there. That's a 19 then. If you say 19, you are wrong.
Sir.
Because it's only 1 mark.
What if I put the approximation signs?
No, here we don't want approximation. We need specifics. It's 1 mark, so one answer. It's 19. And this is not you sketching. You are using the graph that was given. So it means maybe you chose this. Maybe you had a wrong scale. You went with this. That's a 19 somewhere there. Or you went even here. You see here. That will give us a straight 19. If you come to this value here, 0.076. So 19, here it's only one answer, which is 18, nothing else. Nothing else. Okay, all right. We move on to the next one. Move on to the next. The next answer, it says here, a certain anti-acid tablet with a mass of 0.25 grams contains mainly calcium carbonate, which reacts with dilute hydrochloric acid in the stomach, right, to produce carbon dioxide gas. The concentration of hydrochloric acid in the stomach is 0.1 mole per cubic decimeter. All right. We start with the anti-acid. What is an anti-acid tablet? What is an anti-acid tablet? Yes, what's anti-acid tablet? Right. Actually, it's a base. It's a base that you drink to go and neutralize the acid in the stomach. So anti-acid means it's anti-acid. It's going to remove the acid from your stomach. Are we together? Right. Huh? Yeah, you're right. Yeah. So anti-acid tablets that you take to get rid of the acid, extra acid that you get because of drinking your fizzy drinks, your fizzy drinks. They contain a lot of acid, which is going to affect your stomach because the stomach must have a certain concentration. So if there's more acid, it affects the pH of your stomach. So you start to have problems with your stomach. Okay, so that's the point. Yeah. Yes.
So like Eno, sir.
Yeah, yeah. Also, I think Mayo gel for those for kids. I think Mayo gel they use that. Yeah, so they come in different. I think your as well as your I think your Gaviscon they also do the same thing. Yeah. Okay. Yes. Okay, right. So that's the first thing. That's the antacid. So you're going to have to take that. So it is a mass of 0.25, contains many calcium carbonate, mainly calcium. Mainly, what does mainly mean? With a mass of 0.25 grams, contains mainly calcium carbonate, which reacts. Mainly, what does that mean? Mainly. More of, isn't it? Or major part. So if there's major, there must be minor, isn't it? So the major part of this tablet is calcium carbonate. What is the minor? What would be the minor things that you find in an anti-acid tablet?
Hello, sir. Sir, you mute.
Okay, can you hear me now? Can you hear me now? Joshua? Joshua, can you hear me?
Yes, sir.
Okay, right. So I was explaining contains mainly
Yes,
calcium.
sir.
Okay. All right. Yeah, I think the internet is slow. It's slow. So the message is passing very slow. Okay. Right. We have a challenge here. I don't know what's wrong today. Okay. Fine. All right. So I was explaining mainly calcium carbonate. Mainly means there's a major part, then there's a minor part. So this main substance in this particular anti-acid tablet, which happens to be calcium carbonate. And what is the minor? What would be the minor? Huh? The minor. It's still in the tablet. In the tablet, we don't have hydrochloric acid. So your minor part becomes your adjectives, whatsoever they add into the tablet. For example, you're going to find not the coloring, right? Or maybe the flavor. You find the tablet, maybe they put it to make it to be orange like, or they make it to be maybe to be sweet or something like that, so that people can use it comfortably, right? So this becomes your adjectives, becomes the other impurities or the other substances that make up that particular substance. Right, so it means this anti-acid tablet is not 100% pure. By pure, it means it does not contain solely calcium carbonate. There's calcium carbonate and other things, maybe sweeteners, additives, preservatives, or something like that. Right, so it means when you do your calculation, you're not going to take the 0.25% and say that's my calcium carbonate. No, that's not the case. Right. Okay. Then we move on to the next one. The concentration of hydrochloric acid in the stomach is 0.1 mole per cubic decimeter. Define the term concentration of the solution. What is concentration? Right. Whenever you do your definitions, you'll be given the data. So you go to the formula for concentration, which is C is equal to N over V. So this is your definition. When you define your concentration from here, what's your concentration here? Use that formula to put it in words. What is concentration? C is equal to N over V. What is it? N represents what? Number of moles, isn't it? What does V represent? Volume. So your definition must have number of moles and volume. So what do you say? Yes? It is the right number of it will be amount of solute, not solution, amount of solute per given volume or per unit volume. This is the amount of solute per unit volume. Or you can say N represents amount of moles, isn't it? And what is that? What is it that we dissolve in a solution? It's your solute. So it's the amount of solute per unit volume. Or you can say number of moles of solute per unit volume. That's the definition for concentration of the solution. Right, then we move on to the next one. The next one says it is
So
found.
please, can you repeat that?
Okay, it is number of moles of solute per unit volume. Number of moles of solute per unit volume. Number of moles of solute.
Yes.
Okay, right, we move on to the next one, 1.3.2. It is found that 25 cubic centimeter of carbon dioxide is formed when one anti-acid tablet completely reacts. Use the information in the graph and calculate the percentage calcium carbonate in one anti-acid tablet. So like I said, that 0.25 that we have there, it's only the total mass of the calcium carbonate plus other things that are in that tablet. Are we together? Right. But here we just want the percentage of only calcium carbonate in that 0.25 as a percentage. Right. So what do? We are told how much. It is found that there's 25 cubic centimeter of carbon dioxide is formed, right, as a result of using only one tablet. Then the question says use the information in the graph to calculate the percentage. So what do? You go to your graph and check. Right, let's go to the graph and check. On the graph, what do we have? We have got volume and we've got mass. So it means we can, if we have volume, we can get the mass of calcium carbonate. If you've got mass of calcium carbonate, you can get the volume. So you go to 25. I think we're given 25. So you go to your 25 here and check using your graph. Right, system is slow as well. So you got 20, 21, 22, 23, 24, 25. So you're gonna interpolate here along that line. Right, we get there. When you get there, we go down. Right, that will give us 0.1. We get 0.1 here. Our answer becomes 0.1 if I join it from here. Right, I get 0.1. So we have got, is it 0.1? No, it's not exactly 0.1. No. I think it's somewhere halfway. Is it 0.1? Is it 0.1? Okay. Let me see. Let me remove this. Let me see. I just want to double check here. Right, 0.1. Is it exactly 0.1? Okay, right, okay, we give the 0.1, so you get your 0.1. Right, then after you get your 0.1, what do? You go to your formula now. So you're gonna say 0.1. You're gonna say 0.1 divided by 0.1 divided by 0.25 multiplied by 100. This system is very slow. Okay, so you're gonna say 0.1 divided by 0.25, which is that total mass of the antacid tablet. So it's gonna be 0.25. Then you multiply it by 100. Right, what answer do you get? Right, so you get 40%. So this is gonna be over 1. So your answer is 40%. So that's the percentage of calcium carbonate in one antacid tablet. You get 40%. Right, so that's for 3 marks. For 3 marks, you're gonna get a substitution for that 0.1, right, 0.25, and 1 mark for the answer, 3 marks, yes. Huh? What method is this? Oh, the formula. Okay, I can't write it. Let me write it after break. Let me try and check what's wrong with this system here. I'll start with this one so that I can write it down nicely. You know? Okay, guys, we're gonna take a break. Also restart the system here. Check what's wrong with this internet here. All right, so let's meet at 5 minutes to 11. Let's meet at 5 minutes to 11. Please take a break. Then we meet.
Say it's 11 now.
Yeah, 11. Yes, it's break. It's break up until 5
What
to
do you
12.
mean?
Huh?
I'd say you said we must meet at. You just said we must meet at 5 to 11, but it's 11 now.
Oh, okay. 5 to 12. 5 to 12. After 25 minutes.
So
Yes.
So we'll use the same details to log in.
We still rejoin with the same details.
All right.
Sure.